Nowadays, we are in the era of Internet of Things, and along with IoT, lots of technologies are associated, including artificial intelligence. When we work with sensor programming or advanced wireless technologies, resources are major concern, specifically in IoT scenario. In sensor based scenarios, you might have seen that we use different types of gadgets. Nowadays, different so many gadgets available, so many handheld devices available, and not only handheld devices, even vehicular communication that is also going on with wireless technologies. You might have seen in smart vehicular communication when we move. So nowadays, almost every vehicle is associated, it is linked with a fastag. So as soon as we move near to that particular sensor, so that particular payment is committed. Amazon Alexa, that is also wireless based scenario. Fire Stick, and so many other platforms, so many other gadgets or devices we use. So, in this session, we will see which protocols are used at the back end of these implementations. Whether we are using Fire Stick or Amazon Alexa or some particular open source board, we are using FastTag, we are using some sensors, some chips, wireless chips, by which way the actual communication takes place, and how to implement these protocols for our real world scenarios. As all of you are academicians, you might be working on different research projects. So if we want to work on a particular research project related to drone application, so if we discuss about drone, that is also sensor based implementation. Okay, however, a particular device is there, it is flying, it is controlled, but at the back end, communication is wireless communication, and protocols are specific protocols which we use in such type of scenarios. In same way, for example, we are using smartwatch. Nowadays, so many smart gadgets, handheld devices available. So with these smart gadgets, we will see by which way we can work on many realistic scenarios. Okay, so if we are communicating near to a particular object, in that case it becomes edge computing. When we integrate it with satellite, with internet, then it becomes a part of cloud computing. And when all of these things are interconnected, edge, cloud, data centers, in that case we relate it with IoT or IoE, that is internet of everything. Okay, so we will see by which way we will be able to work with these scenarios, and if we want to work on some particular research project, then how to work on those. So before covering any practical demonstration, first of all, we will see different use cases, different realistic use cases which are implementable. So swarm drones for military applications. So obviously this is also possible with advanced wireless protocols. And if we want to communicate with these drones or with n number of drones, then obviously we need a particular lightweight protocol, lightweight implementation scenario. So one lightweight protocol we will discuss in this session, that is MQTT, message queuing telemetry transport, that is widely used in advanced wireless networks, IoT, and specifically in low resource scenarios, low resource gadgets. If we are having a particular smart gadget, if we are having some drone, some handheld device, so obviously in a small size chip or in a small size device, we can't install a complete server. So if we want to work with these implementations, for example, computer vision based application for law enforcement, and very quick communication is required. So vehicular and number plate detection, okay, vehicular communication, for example, in fast tag you might have seen a particular chip is there. So as soon as that chip is uh, in communication with a specific sensor, then that specific implementation or operation is committed. By which way it is possible? With specialized protocol, either MQTT or LWM2M, lightweight machine to machine protocol, AMQP, advanced message queuing protocol, okay, and lots of others. In same way, for example, you want to work with some intelligent application with wireless for agriculture domain. You want to develop some agribots, agriculture robots, and those agriculture robots we want to control with a laptop, with mobile phone, with Android app or iPhone app. So by which way it will be possible? It will be possible with implementation of very high performance AI based protocols, artificial intelligence based protocols, and along with that those protocols are lightweight in nature. Okay, industrial automation, for example, we want to work with such type of implementation. Smart ambulances, if we are proposing some research project related to smart ambulance or electronic health services, in a specific ambulance, if it is moving on remote highway, then how to communicate with medical lab, how to communicate with a specific medical expert. So what we can do, we can place some sensors, and whatever readings are associated with human body, so those readings we can post or we can broadcast to remote medical expert, and in real time that particular medicine can be injected in human body, okay, for survival to some particular time till that patient moves to that multi-specialty hospital. So there are lots of scenarios where we need very efficient protocols, high-end protocols. Okay, robotic surgery, 5G powered medical robots. These are required. Okay, nowadays you might have seen in most of the multi-specialty hospitals, robotic surgery is integrated, and obviously it is possible with integration of advanced wireless protocols, advanced wireless networks, 5G, along with that some particular software suits, high-end software suits, okay, smart health services, and telemedicine. So up to now we have seen different use cases. Okay, we can work on robotic surgery, 5G powered medical robots, we can work on agribots, agriculture robots. For law enforcement we can work with some particular drones, but how to implement it? Now we will see which protocols are available to implement these scenarios. So we will discuss about one very specialized protocol that is used in advanced wireless networks in whatever generation based network you are working, whether you are working on 3G, 4G, 5G, or so on. Because nowadays we are not only working on a particular wireless generation, along with that we are working on some gadgets, we are working on some sensor based implementations, and when there are some sensors, then obviously we need interfacing, sensor interfacing. Okay, whether you are working on 6G, 5G, but sensor facing is still required. Okay, so which protocol and which software we can use? For example, you are using Raspberry Pi, you are working on Arduino board, you want to work with some PCB. Okay, but at the back end of these devices, these platforms, which protocol we can use or which protocol is implemented, that is message queuing telemetry transport, MQTT. This demonstration we will see in this session with free and open source software products. Okay, any number of sensors we will be able to link with it, whether you are using humidity sensor, temperature sensor, you are working with some law enforcement agency based sensors, you are working on some electricity or fume sensor. In every scenario we will be able to work with MQTT. For example, this type of implementation we want to work with, we are working on some Arduino board or Raspberry Pi. Okay, in that, with that Raspberry Pi or board, we have linked different sensors. Okay, temperature sensor, oxygen sensor, and these sensors are receiving data, these are capturing data from human body, from patient. So what we can do, that particular Raspberry Pi board or Arduino board, we can link to mobile app. We can link with Android app or with laptop dashboard. So what it will do, it will give us a scenario of advanced wireless communication, and that will be a flavor of IoT. Okay, so such type of research projects, such type of research implementations, we can work with MQTT protocol. Now we will see how to work on that. Up to now, is it clear to all participants? Are you getting audio and screen clearly? Kindly confirm in chat. Whatever we are discussing, is this clear to all of you? Are you getting the content properly? So, for example, this type of scenario, okay, health monitor. So we will see which is that specific software suite, and if we are doing research in this area, then which free and open source utilities are available. So obviously if we are doing research, if we are working on some research project, many times we stuck at the part of resources. If I want to integrate n number of sensors, obviously it will be very difficult to purchase some boards, some sensors. We want to deploy, we want to work on some simulated scenario. I will show you some simulations by which way we can work on these implementations with simulated scenario without using actual sensors, without using actual devices. Okay, so first of all, we will see which software is available or which libraries are available for implementation. If I want to implement MQTT protocol for advanced wireless communication, for our implementation, for our research based simulation, then we have some free and open source products, and Mosquito is one of that. Eclipse, Mosquito, open source MQTT broker. Okay, so you can see that this one, and it can be used on any type of device. Okay, useful for all devices from low power single board computers to full servers. Even you will be able to use it on Android phone, on any type of gadget. So this one, you can see that Eclipse Mosquito for IoT messaging, for wireless based communication. Another platform that is also available in free distribution, that is Hive MQ. This one. If you want to work with a particular industrial automation, its interfaces with different programming languages are available. So you can see that this one. If you want to work with smart automation, industrial solutions, this one, logistics, energy, and we want to connect multiple devices, we want to connect different gadgets with our dashboard. If I want to create this type of scenario, this type of dashboard, for example, okay, so whatever data is moving on, whatever calculations are going on in remote gadget, that we will be able to govern, that we will be able to monitor. Okay, so this one, hive mq, rabbit mq, okay, rabbitmq.com, any of these you will be able to use. So you can see that, and cloud variants are also available. So you can see reliable and mature messaging and streaming broker. So which use cases we can integrate? So if you want to work with IoT, so drone application, if you are working, if you want to control your drone devices, if you want to control your vehicles, if we want to work with smart home automation, smart office automation, we want to link different gadgets, different devices in our home or office campus. So any of these you will be able to use, and these MQTT products are available as free and open source. Okay, so you can see low power sensor or mobile devices, phones, embedded computers or microcontrollers. Anywhere you will be able to work with it. So for example, I want to work on a research project, and in that research project we want to use different drones, different sensors for electronic health services or smart home automation, smart office automation. In that case we can use it. So what we will do, we will we will be able to download it. Okay, if you want to download it in laptop, that is also possible. So you can see cross platform software, mosquito, on windows, mac, linux, or Raspberry Pi, Ubuntu, anywhere. So wherever you will install this software, for example, you are installing this software in Windows-based system. So that particular Windows-based system will become message broker, wireless message broker, communication or message broker. If you are installing in Android phone, that Android phone will become message broker. In same way, if you are installing in Raspberry Pi, that particular Raspberry Pi will be able to control or monitor different devices which are attached to that particular Raspberry Pi or that specific system. Okay, in same way, for example, I'm using rabbitmq or hivemq, all of these are completely free. Okay, so if you have downloaded and installed rabbitmq in your laptop, so your laptop or your system will become message broker, communication broker, and what we can do are nearby gadgets, nearby devices. Okay, for example, you have car, okay, vehicle. So your fastag, your vehicle, your chip, that can be linked with this particular mosquito broker. I want to link this mosquito with home appliances, with AC, with LED, with LCD, with different other gadgets, that we will be able to do. So by this scenario, what will happen? I will be able to control all of my nearby devices, all of my nearby gadgets with a single laptop dashboard that is available as Mosquito, or with my mobile phone, via Android app or iPhone app. Okay, so you will be able to work on it. Now we will see by which way we can give a graphical user interface. For example, this software we have downloaded, okay, Mosquito or RabbitMQ we have downloaded. That is fine. We want to work with it, but which particular software we have to integrate to give it a graphical user interface. To work with graphical user interface for advanced wireless and IoT IoE scenarios, we use one very popular free and open source software, that is Node-RED. This one, Node-RED. This is also available in free and open source distribution. Low code programming or no code platform. Without writing even a single line of code, we will be able to control our gadgets. We will be able to control our devices. For example, I want to control LED, LCD, or vehicle, or some particular refrigerator or AC. So what we will do, we can create a GUI in Node-RED in this way. This one. Okay. And by which way communication will take place? Communication will take place via MQTT. Okay, so MQTT will perform communication part, interfacing part, or dashboard or GUI will be given by Node-RED. Okay, so these two things are different. If I want to create a dashboard, if I want to create a diagram, flow based diagram, so this is known as flow based diagram. I want to create a dashboard. So that dashboard will be created with Node-RED. Communication will take place via MQTT. Okay. Sensors will retain as it is. So this one. Where we want to work with it. On which devices we want to work with dashboard creation. So it's up to you whether you want to work with laptop, okay, or your server. You can use Docker or local distribution. If you are having Raspberry Pi, device agent, Android phone, Arduino board, BeagleBone Black, on open source hardware, we will be able to work. We will be able to create a scenario. If I want to work on cloud, Flowfuse, Amazon Web Service, Microsoft Azure, that is also available. So anywhere we will be able to work with it. Are you getting these points? Kindly confirm in chat window. Are you getting these content properly? What we are discussing here? Okay. So you can see. So I will show you a collective implementation, a collective scenario using Node-RED as well as MQTT. Okay. So first of all, I will show you one scenario related to Node-RED. Okay, so you can download it on Raspberry Pi, Flowfuse, BeagleBone, Android, or anywhere. If you want to work on cloud, then its cloud is also available. Okay, so one of the very popular cloud-based platform, AI-based platform is Replit. Replit Bolt. Bolt is also available. Bolt.new, or you can deploy Replit. Okay, so we will see how to deploy Node-RED on Replit platform. So you can see that you can create account on Replit, and here we will be able to work with Node-RED. Okay, so you can simply create the app. It is AI based platform, and it will give you access to different programming languages, different programming platforms. So you can see this is Node-RED. One app I have already created. This is already installed. So you can see that this is Replit platform. Now I want to run my Node-RED. As Node-RED I have already deployed on Replit run. Now you can see that it is running now. So you can see this one is running, and this is Node-RED for creating a dashboard related to wireless networks. Okay, if I want to open it on separate system, on separate window, so this QR code is available. I can scan this QR code. Okay, or I will open this link. Simply click. This is developer URL. Click, and now Node-RED will be opened separately in new tab. So this is dashboard to work with that specific wireless scenario. I want to create an IoT scenario, advanced wireless based scenario, 5G or 6G based simulation. For example, your area of research work is related to 5G network, and in that you want to work on cryptography, encryption, you want to work on congestion control. So one way is that we use NS2, NS3, MATLAB, Vilenta, Qualnet, so many thousands of simulators available. But in most of the network simulators, generally we have to code, we have to write the script. But in Node-RED, there is no need to write any script. Simply drag and drop. So you can see whatever we want to link, whatever we want to take. So I want to work with MQTT, simply drag and drop. I want to work on WebSocket, drag and drop. Okay, whatever block is required, that we can link with it. I want to work on file handling, write file. Simply drag and drop. Control Z, undo, in this way. In NS2, we have to work on TCL scripts. So if you have worked on that platform, you might be knowing. In MATLAB also, we have to work on some particular code. We have to write a particular function or block. But in case of Node-RED, no need to write anything. Simply drag and drop. For example, this is inject. I want to take a timestamp. Okay, double click, initiate communication. Okay, done. Debug to print message, display output on screen. Okay, or display output. Done. Now I want to link it. Simply drag and drop. Simply connect. So you can see I will drag it and drop. So now this dashboard, now this very simple scenario is created. So you can see that I have not written even a single line of code. I have not written any program. Simply dragged, dropped, and linked. Now if I want to run it, I want to run this scenario. At top right, deploy. Click. Now I will click here. Okay, so you can see this is the output window. Now at right hand side you will see the output. Here you will see the output. So I am clicking here. Click. So you can see message payload we are getting. Okay, without writing any script, without writing any code. If I want to if I want to change this particular output format. Okay, so system console, node status, done, deploy, and you can see that it is running now. So this is very simple, just to make you comfortable, just to show you by which way we can work on this type of implementation. Now if we want to work with a scenario related to IoT, related to wireless network. Okay, so in that case what we will do. So during this session, we have discussed about one protocol, that is MQTT protocol. Now I want to integrate MQTT protocol. So I will disconnect this link. Click on this. Click on this wire. Okay, this is the communication wire or link. Click and delete. Now it is deleted. Now there is no connection between this initiate communication and display output. In between initiate communication and display output, I want to put MQTT. Okay, so this is MQTT. It is already available. connect to MQTT broker and publish messages. So you can see this one, connect to MQTT broker. Now drag. Okay, I will put here. So you can see drag and drop. I'm not writing any code. We are not writing any script. Simply we are creating a design. We are creating a dashboard. We are creating a graphical user interface. Connect this with MQTT and one link we will connect with system console with system output. Okay. Now whatever input we want to process, so you can see this one, which particular MQTT, for example, so it is asking for the MQTT broker plus. Now here we have to specify the credentials of MQTT broker. What is meaning of credential of MQTT broker or advanced wireless messaging broker? In whatever device we have installed MQTT, IP address of that, okay, or credentials of that we have to put. For example, we have downloaded and installed Mosquito in Raspberry Pi. So credentials of that Raspberry Pi will be put here. If I have installed in laptop, so credentials of that laptop, IP address, port number, that we have to specify. Okay, now for demonstration, I'm taking one cloud-based MQTT, and one cloud-based MQTT is test client. This one, this is available for testing, for research-based implementations. This one, okay. So which topic? For example, X topic. Subscribe. Okay. Now what message? For example, this one. This is test client. So what we can do, for example, I want to connect my AC with this MQTT broker. So what in that case we will put these details. We will put this credential TCP broker dot MQTT dot cool. This one, IP address. This is URL and this is port number, and it will be linked. So this I want to place here, this one. Okay. Security, if we have some username and password we can put. Messages, okay. Leave, you can see birth message, and this is MQTT communication broker. Now we can place some particular topic also, add, which is the topic X. Done. MQTT broker. Done. Deploy. Now you can see it is connected. MQTT, now it is connected. Now I will click here, run. So you can see that this message is received here. So one more click I will, so you can see I will click once more, click. So you can see that that particular message is coming here. If you want to put a message in this way. So what we are doing, we are creating a dashboard. So for example, this one is for AC. Okay, one more we are creating. This one is for LED. This particular communication we are creating for LED. Okay, double click, LED. Done. Deploy. Now you can see these are connected. Okay, without writing even a single line of code in Python or in C++ or in any programming language, we are creating a graphical user interface, we are creating a GUI dashboard, and we can work with it. Simply click here and this message will be received here. So for example, our washing machine or oven or led or lcd is linked with this particular credential. So same credential will be put in that led, that particular device. Same credential we will link with our node-RED platform. Instructions will be given by node-RED. Okay, so click here and it will be received at this point. If you want to put here this one, washing machine on or off, okay, or AC on 20 temperature in this one. So as soon as we will click here publish, it this particular message will move to that particular device and appropriate action will be taken remotely. If we want to store this particular data in a text file, for example, we want to implement machine learning, deep learning, we want to perform some data analytics part. So write file. So you can see this is write file at bottom left. Simply drag whatever signals we are getting. Simply we will link. So simply select and link with it. Now this is write file. Okay, so output will be placed here. So double click what is the path in C drive or my signals dot txt. Okay, dot txt or dot csv, wherever we want to store we can work on it. Okay, are you getting this process? Kindly confirm. Is it understandable to all of you? So very simple scenario we are creating. So what you can do, you can create an account on Replit, and this is cloud based platform. Okay, AI based portal, and in this you will be able to install node-RED. Okay, if you want to perform some additional operations, some other operations, for example we want to put some logic, some business logic, some function, some switch. Okay, mathematical functions we will be able to integrate. If I want to attach some additional service, we want to link with some additional board. For example, I want to link it with a 5G network. Then how to link with that particular 5G network or that specific module? It is completely free and open source, fully extensible. So you can see here at top right, these three lines. Okay, this is the icon. Click manage palette. So you can see manage palette. If you want to edit it, so many features available. You can see if you want to export this particular scenario. Now manage palette. Manage palette means whatever blocks we are having in left hand side. So you can see in left hand side we have inject, debug, catch. Now there is no block related to Raspberry Pi. There is no block related to Arduino board. I want to link with Arduino board. I want to use ESP8266. I want to use Wi-Fi. So for that, simply click here, manage palette. Click install. Now I want, so you can see how many modules are available. More than 5,000 modules. Okay, so you can see more than 5,000 modules are available, and all of these modules are completely free and open source. I want to use Wi-Fi. Okay, so you can see Wi-Fi module is available, so I will be able to install it. If I want to see its documentation, so that is also available. So this is node-RED contrib Wi-Fi module. So if we install this Wi-Fi module, then we will get a Wi-Fi icon in left hand side. In same way, Raspberry Pi. So you can see Raspberry Pi. So many modules related to Raspberry Pi. In same way, for example, 5G networks. 4G networks, okay, or Arduino board, okay. If I want to work with third party application, Thinger, ThingSpeak, that is also available. I want to work with street map, open weather map. So you can see, click here, we will be able to work with weather forecasting. So if we are working on agriculture domain, if we want to create a scenario to find out to work on agriculture segment, so simply click on install, and very soon it will be integrated, okay. So whatever module is there, it will be available, okay. So as far as MQTT is concerned, as far as other blocks are concerned, you will be able to work with it, okay. So you can use, for example, you want to work with TCP, so you can see, you can link with it, okay. This one, TCP in, TCP out, you want to send this to TCP, okay. If you want to link, so simply manage palette, install Wi-Fi, okay. So if you want to see its documentation, it will be installed. So for this type of implementation, your internet speed should be fast, so that automatically this block will be installed in your scenario, okay. Otherwise it will, that particular installation may fail in between, okay. So you can work with it. So deploy, reload, loading palette, and now you can see this one, deploy, and it is connected, and this one, same messages we are getting here, this one, okay. So by this way we will be able to link with MQTT protocol, and we can work on interfacing part, okay. Now one more platform we will discuss, we will see in demonstration, related to wireless communication, related to smart gadgets, okay. So after completion you will be able to uh, stop it. So you can stop all overflow, all flows, this one, this is console, and you will be able to close it, replicate, okay. Up to this point, is it clear to all participants? Kindly confirm, is this clear to all participants up to this point? Node-RED and MQTT interfacing to create a wireless scenario. Okay, so this presentation I will share to all of you at end of the session, so that you will be able to work on it. Okay, at end of this session, this PPT will be shared to all of you. Okay, this is the presentation. In this presentation, every link is given, so by which way you have to work on it, and what about MQTT protocol, what about MQTT broker, and by which way we have to work on it. Now, one more platform we will discuss, that is known as this one, mydevices.com, for simplified sensor deployments. My devices. Many times for research work, we have to take actual sensors, actual connectivity products. As a research scholar, as a researcher, as an academician, sometimes it may be difficult to purchase so many sensors. My devices platform gives us access of virtual sensors. So you can create account on this platform. Okay, so I'm logging in here. After logging into my devices portal, you will get this dashboard. If you want to work with virtual sensor based scenarios at a particular location, you can use it. So you can see that. Now add new. Okay, so this is the dashboard. This is dashboard. Okay, so scenario 1. In that particular scenario, what we want to take, which type of device, which type of gadget we want to integrate. So you can see what we want to work with the temperature, signal strength. We want to take some sensor. We want to take some widget. Okay, now we will see. So you can see that this one, for example, this one, widget settings. Which widget we want to take? So it is giving us complete configuration. Okay, so that we can link with it. So certain scenarios we have already created. I will show you. For example, we want to work with a scenario, a particular dashboard with humidity sensor, with a temperature sensor, with fume sensors. So you can see this one, menu, add device, reports, add asset. Now I'm taking this option, add device. Which device I want to take? Rather than taking any physical device, if I'm having access to actual device, I can use that. Rather than that, rather than purchasing actual device, we can have its simulation. So you can see add simulated device. Loads of sensors in simulated way, in simulated format will be available here. For example, one sensor is available in $500 or $2,000. So rather than purchasing that sensor, we can use its simulated version to get output, by which way it will get that particular output. For example, this one. So you can see every sensor is available here. So this is humidity sensor. If I want to check what is price of this humidity sensor, okay, separately we can check. So you can see $42 it is given here. This one is $42. So rather than purchasing this sensor, this in $42 or 40 or round of $43, I can simply use its simulated format. Okay, so this one, okay, or any other. So add device, click on add device. Okay, for my research work I want to use it. Device use, where I want to use. So you can see in room, refrigerator, freezer, room. What is unit? Fahrenheit, Celsius. Add device. Okay, so you can see that without purchasing any sensor, without buying any sensor, whether it is in $1 or $10,000, we can take its simulated scenario. It's a simulated version. Its readings can also be taken for our project work. Okay, so you can see that this one and done. If you want to put some alerts, done. If you want to give it some longitude, latitude, if you want to attach it with some particular location, click. So settings, to some particular location we want to attach. Okay, so you can see that this one, this is private URL, public URL. If we want to view it from anywhere, okay, chart of the data, this one, settings, okay, this one. And after taking the readings, after working on it, we can delete it. Resources, data sheet, activity log. Okay, by which way we added this specific simulated scenario. Okay, we want to delete it. After taking all readings, we want to remove. Confirm. Now one more device, one more gadget we want to take. Add device. Add simulated device, or you can take QR code also. If you have actual device, you can put device ID and it will be verified whether it is authentic or not. Add simulated device. Now which type of sensor we want to take, so you can see thousands of sensors available for every process, for every implementation. Humidity, Bluetooth, temperature, infrared, smart current transformer. Okay, if I want to see price of this, so you can see that in how much price it is available. $149. Okay, around $150. Rather than that, we can use it in simulated format, in simulated way. Okay, laser, distance sensor, in same way, vape detector, magnetic sensor, tile sensor. So all of these are available. So any of these we can use for our project work, for teaching and learning also. Okay, so you can see this one. If I want to use it, for example, this one, add device. Okay, so without purchasing it, we are taking its only simulated format, simulated version. Where we want to use, this is device ID. Where we want to use room breezeway, show advanced options, add device. Okay, now done. Real time data will be accessed. So this one device use, and any number of gadgets, any number of sensors can be linked. So if we want to plot some charts, so what about signal, smoke alarm, battery level, okay, map, this one. We want to use it at a particular location. We want to integrate a map. Okay, so this one. So you can see that this one. This is satellite view. Okay, so linking with some satellite image, some point, it can be done. And after that, we will be able to log in. We will be able to capture the results. Okay, so anywhere, any particular point, we will be able to navigate, and after that we can see, okay, this one, for example, this is our sensor, and we want to take this data. So if I want to download this data, so on click of this, data will be downloaded. Okay, day wise, week wise, month wise, or specific timeline wise data we will be able to access. Battery stats, high temperature alarm, signals, and smoke. In same way, we will be able to work with simulated gateway. Okay, so this is scenario polysense, and now add asset. We want to link some asset, or we want to link some device. Add device, sensor map, some alert. So multiple sensors we have attached, and we want to get some alert. Add simulated gateway. Which gateway we want to use? So you can see gateway ethernet cellular, which we want to link. For example, this one Bluetooth gateway, or this one. Add simulated device, add gateway. If you have actual device or actual gateway, you can use. If you want to get simulation, then you can work on that. So air quality index sensor we want to attach. So these are hundreds of sensors. So if we want to see its price, so $1,000. So you can see that LAQ for $1,000, LoRaWAN air quality sensor. But here we will be able to use it in simulated way, For smart home automation, smart office automation, okay, smart home automation, in which mode? Fahrenheit, Celsius, add. We want to add it. Where we want to link this air quality sensor, okay. So you can see by default it is attached to location. I want to change this location, sensor map. Where we want to place a sensor, virtual sensor. So satellite view, okay. So simply we will be able to select, and once it is done, then you can see that it is linked, and once it is attached, then we can access the data. This one. If I want to download this data, so click here. So historical data or current data, chart. We want to plot some charts, signal strength, battery level, CO level, and smoke alarm. Notifications, if we have placed some alerts, we can go for that. If we want to download this complete data, it can be done. And so this one, and now you can see request download. So simply click here and data will be available. So on this particular data, we will be able to work on machine learning, deep learning, data analytics, or any other implementation. So by this way, we'll be able to work on virtual sensors in my devices. Okay, mydevices.com. This presentation I will share to all of you so that you will be able to work on it. Simplifying sensor deployments. So many companies are using it for data analytics, for data exploration, and for research work. You can use it. Okay. Now, dear participants, I am sharing this presentation to all of you so that you can work on it.